So we suppose if you have any expansion of this n equal to 0 to infinite a n into x power n. This is what we call power series. Okay. And another type we can have it here is a n into x minus a whole power. So this is what we call power series centered at a. Let me start with some problems. Here you can see the power series general form. This is the general form of the power series centered at a. And here you can see some examples of power series. Right? So here the question is we need to know all values of x for which the summation is convergent. Okay, so as a first problem, let me take the first one. Okay. So now you see this summation a equals to 1 to infinite minus 1 power n minus 1 x power n over n. Right. So here if you when it comes to power series, remember one thing, we always apply either ratio test or root test. These are the two tests we mostly use for power series. Okay. So here I'm going to use ratio test. So let me apply ratio test to know at which it is absolutely convergent. Okay. So what I need to do is I need to write an first. So the an is going to be minus 1 power n minus 1 into x power n by n. And similarly you may write an plus 1. That's minus n 1 power n. And we x power n plus 1 over n plus 1. Okay, so in the ratio test, we take limit n goes to infinite. We take absolute value of the ratio. An plus 1 over an and its absolute value. Now you can forget about that minus 1 to the power of n minus 1 and all, because we are taking absolute value. Okay, so limit n goes to infinite. What happens now? This is x to the power of n plus 1 by n plus 1 modulus of into this is n over x to the power of n. So let's simplify this. Limit n goes to infinite. So if you simplify, you'll get mod x times n over n plus 1. Because x power n cancels and we left with it. And the limit is independent of mod x, right? So it depends on only n. So mod x we can bring it out. So this is limit n goes to infinite. Yeah, I hope this one can be rewritten like this: 1 over 1 by n. Right? So finally the limit would be mod x into 1 by 1 plus 0. So you got mod x. Okay. So in the ratio test, we got the limit as L, and we know that if L is less than 1, then it is absolutely convergent. It means we can conclude that therefore given series is absolutely convergent if mod x is strictly less than 1. Okay, mod x is strictly less than 1, then definitely it is absolutely convergent. So it means that minus 1 is less than x is less than 1. Okay. So now we got two endpoints. One is negative 1 and another one is positive. So basically at endpoint what happens? Mod x value becomes 1. It means in the ratio test we got limit as 1. But when you get limit 1, we cannot conclude using ratio test. So what we will do is at endpoints we need to go for further investigation. That is when x is equal to minus 1, we need to see. So what is the given summation? n equal to 0 to infinite minus 1 power n minus 1 into x power n, that is minus 1 power n by n. and this equals summation n equals 1 to infinite. So m optimum is minus 1 power n into minus 1 power n. That becomes 1 into again minus 1 power minus 1. So that gives you minus 1 by n. I hope you can see that. Okay. So what can you say about this? Is it convergent or divergent? So is it convergent or divergent? This summation. Can someone tell me? Sorry, here I should not start with 0 because n cannot be 0. N equal to 1. It is there in the denominator, no? Okay. Can someone tell me, is it convergent or divergent? Yeah. So it is divergent, correct. So therefore at x is equal to minus 1, at one end point, the summation is divergent. Okay. So let me go for the another end point, that is x is equal to positive 1. So at x equal to positive 1, this is summation n equals to 1 to infinite minus 1 power n minus 1 into 1 power n by n, which is nothing but summation n equals to 1 to infinite minus 1 power n minus 1 by n. And what do you know about this summation?
Divergence, sir.
So the given series is absolutely convergent in between negative 1 and 1 and conditionally convergent at x is equal to 1. Okay. So we can write the interval of convergence now. So therefore interval of convergence, the interval of convergence is at minus 1 it is not convergent, and at 1 it is convergent, but it is conditionally convergent. So this is the interval of convergence for the given power series. And the radius of convergence. So the radius of convergence means that from the center to end point. The distance between the center to end point. That is 1 here. Therefore the radius of convergence r is 1. So this is how we need to conclude whether the given for what values of x the summation is convergent or divergent. So here you have to use alternating series for sure. Okay, at the end point, most of the times you will end up with alternating series. When it comes to the alternating series, you need to decide whether it is absolutely convergent or conditionally convergent. Okay, now let us look at this problem. Summation n equals to 1 to infinite minus 1 power n minus 1 to x to the power of 2n minus 1 over 2n minus 1. So same as earlier. So you'll apply ratio test. So I'm directly writing here. So if I go for limit n goes to infinite, absolute value of an plus 1 over an. This would be limit n goes to infinite. So this will be x to the power of, if I plug in n equal to n plus 1, then it will get 2n plus 2 minus 1, finally 2n plus 1 you will get. Over the denominator also you'll have 2n plus 1 times 2n minus 1 over x to the power of 2n minus 1. So limit n goes to infinite. And what happens is this becomes x power 2n plus 1 minus of x power in the power you'll get minus 2n plus 1, so you'll be left with x square. Okay. So you'll be left with x square here, x square into modulus of x square into you have 2n minus 1 over 2n plus 1. So finally what you're getting here, so this is minus 1 power n. So minus 1 power n over 2n minus 1. I hope here you can see the simplifications of all this. Okay. And now you tell me, is this convergent or divergent or conditionally convergent or what? Absolutely convergent. So this one, if we observe that, it is actually similar to summation 1 by 2n, yeah, minus 1 power n. So we know that summation minus 1 power n by n is conditionally convergent. So we can conclude that this summation is conditionally convergent. And no need of writing details. Okay, if you want to really want to write the details, then you need to write alternating series test here. Okay. So the alternating series test is the only one which is going to help you in showing that it is convergent. And the other one, when x is equal to 1, is summation n equals to 1 to infinite minus 1 power n minus 1 into 1 power 2n minus 1 over 2n minus 1. So what is it? N equals to 1 to infinite minus 1 power n minus 1 by 2 to the power of 2n. Sorry. In the denominator you have 2n minus 1. Okay, so how about this one? How about this summation?
Conditionally convergent.
So this is also conditionally convergent. So therefore this is conditionally convergent and at both endpoints. So therefore what is the interval of convergence now? Interval of convergence is, so that is negative 1 is included and positive 1 is also included. Okay. And we can write that it is conditionally convergent at plus 1 and negative 1. At these 2 points it is conditionally convergent. At the other points it is absolutely convergent. And what is the radius of convergence? So radius of convergence, so that equals to r equals 1. Why? Because from the center you move the distance one unit. So let's discuss something interesting about this power series. And this power series has a very nice property. For example, if we take a power series, let's assume that you have taken a power series and which is centered at some point A. So the power series is centered at A. So suppose that if you came to know that the power series is convergent at this point, for example at maybe C, we came to know that the power series is convergent. Okay. And the interesting thing here is that you take a neighborhood around A with the distance of C. Okay. It means from here to here. So in this interval, the entire summation is going to be convergent. Okay. So you take the center, for example, for time being, I'm taking the center to be 0. Let me take the center is 0. If you know that the power series is convergent at let's say 3, then definitely for all x which belongs to negative 3 comma 3, for all these values, the power series is going to be convergent. And one more thing is that suppose if you know the power series is divergent at 5. Okay. So at 5 you came to know that it is divergent. And here it is actually convergent. So then definitely after 5 it is going to be divergent, and not only after 5, before negative 5 also, it diverges. So that is the nice property this power series is having. Okay. So if you know that it is convergent at one point, then you do one thing. From that point you take the center, and again from the center you go the other side. The same distance. So in that entire interval we can say that the power series is convergent. Okay. So I'd like to ask you one question here. Suppose that I'm giving you a power series here. Summation n equals to 1 to infinite a n into x minus 3 whole power n. And this is convergent at x is equal to 5. Okay. So now, what can you say about at these points? Let's say the first point I'm taking here is at x is equal to 4. What can you say? At x is equal to at x equal to 2. What can you say? And at x is equal to 6. What can you say? And at x is equal to let's say 1. What can you say? Tell me. At x is equal to 4. Can we conclude anything?
Convergent.
Yeah. So here you see that you're taking the center. The center is at 3. This is the center. Okay. So you came to know that at 5. This is 4, and at 5, this is convergent. So from 5, you'll come to 3, and again you move the same distance. It means 2 units. Yeah. So this on this entire interval, we know that the summation is convergent. This is what we can conclude. Therefore, at 4 it is convergent. And what are the other ones? 2, 1, right? So at 2 it is convergent. And at 6 we don't know. Because I am not telling that after 5 it is divergent. All that I am not saying. I'm only saying that it is convergent at 5. After 5 it may be convergent or may not be convergent. We don't know that. Okay. So that's why at x is equal to 5. I wrote we don't know. How about at x is equal to 1? Even at x is equal to 1 also we can't say anything. Why? Because you started at 5 here, right? And it may be end point of the interval on the other side. At the end point, the summation may be convergent or may not be convergent. Let me just after 1 I say, okay, I am very sure it is convergent. But exactly at 1 and before 1, I do not know it. Similarly, for example, you came to know that for the same problem. This is 6 at 7. Okay. So at 7 you came to know that this is divergent. Okay. So if I take some more points here, like x is equal to 8 and x is equal to maybe negative 5 I'll take. So what can you say about x at x is equal to 5, at x equal to 8 and 5 to 5? At 7 it is divergent. It means from 7 onwards it's going to be divergent for sure. So what is it at 8?
Divergent.
Divergence.
Yeah, this is going to be divergent. And how about at x is equal to negative 5?
Divergent.
Because since 8 is here, you are saying that 5. Okay, so the negative 5 I need to see how far from the center that I have to see here. So where is negative 5 actually? So the distance between okay. So now the distance between 3 and negative 5 that I have to see. So initially the distance between 3 and 8. So that is 8 minus 3, which is actually 5. Okay. From 3 you try to construct a neighborhood of 8 ka then actually 7 ka. So then I must see the distance between 7 and 3. Yeah. So that gives me 4. The 3 దగ్గర నుంచి 4 units ఇక్కడ ఒక radicular one construct చేయండి divergent line. And 4 దగ్గర నుంచి negative 4 units will move over. 3 minus 4. So that gives you negative 1. So negative 1 it means somewhere here. And from here onwards it started diverging. Okay. So the negative 5 which is before negative 1. So no issue. So we can say that here it is diverging. Okay. So here I am going to show you a theorem. That's what exactly discuss this. So convergence theorem for a power series. What is the convergence theorem for power series? If a power series summation a x power n converges for x equal to c, then the series converges absolutely. Not only just converges, it actually converges absolutely for all x where mod x is less than mod. Okay, ఇక్కడ సెంటర్ వచ్చేసి 0 దగ్గర తీసుకుంటున్నాడు. అందుకనే డైరెక్ట్ గా mod x is less than mod c అని రాస్తాం. But center different తీసుకుంటే you have to be careful. Now if the series diverges at x is equal to t, then it is going to diverge for all x which is greater than absolute value. So ఒక పాయింట్ దగ్గర కన్వర్జ్ అయితే ఆ సెంటర్ దగ్గర నుంచి ఆ పాయింట్ వరకు అటు ఇటు కూడా కన్వర్జ్ అవుతుంది. అదే ఒక పాయింట్ దగ్గర డైవర్జ్ అయితే సో ఆ పాయింట్ కి ముందు అలాగే సెంటర్ దగ్గర నుంచి మనం ఆ పాయింట్ డిస్టెన్స్ చూసుకుని అవతల వైపు కూడా సేమ్ పాయింట్ కూడా కన్సిడర్ చేసి సో బిఫోర్ అండ్ ఆఫ్టర్ that particular number we can say that it is divergent. It's like that. Okay. So this is what convergence theorem for power series. All right. So the next thing. Yeah. So here we know some summations, right? For example, 1 by 1 plus x. I hope from the geometric series you can obtain this summation. 1 by 1 plus x summation is nothing but 1 minus x plus x square minus x cube plus x power 4 minus x power 5 plus and so on. Okay, in this you can easily see it from the geometric series. You know that this is convergent for all mod x strictly less than 1. There only it is convergent, right? Now so this is the expansion using geometric series, right? And you know that this geometric series is convergence to 1 over 1 plus x when mod x is strictly less than 1. Okay. So now I want to do one thing. I'd like to take x square in place of x. Okay. So I'd like to put x square. So if I take x square in place of x, 1 over 1 plus x square would be 1 minus x square plus x square whole square, that will be x power 4 minus x square whole cube, that is x power 6 plus x power 8 minus x power 10 plus and so on. Yeah. So what simply we did here is replace x with x square. So this is what we did. Now I'm going to do one thing. I'd like to find the expansion of tan inverse of x. This is what my aim. So if I need tan inverse of x, we know that it is simply integration of this expression, right? Integral 1 by 1 plus x square will give us tan inverse x. So on the other side also you integrate and you try to find the summation. Okay. So that's what the next theorem is talking about. Term by term differentiation or term by term integration. So let's try to understand what it says. So you have a power series and you know it is convergent for this interval where mod x minus a is less than r. So here it is convergent. it says that this theorem says that we can take the derivative of the function, and these derivatives can be taken from inside like this. అంటే ఇక్కడ మనకి f dash of x f of x అనేది ఈ సిరీస్ ఎక్స్పాన్షన్ ఉంటే f dash of x వచ్చేసి ఇక్కడ టర్మ్ బై టర్మ్ డిఫరెన్షియేట్ చేస్తే సరిపోతుంది. Okay, so we can obtain the derivative by differentiating the original series term by term. So this is what we call term by term differentiation. To obtain derivative of a function for which you already know the series expansion. Okay, so I'm going to apply this term by term differentiation to find the expansion of tan inverse x. So this is what we are doing here. Of course, I'm going to use term by term integration. Alright. So here let's do one thing. Integrate on both sides. Integrate term by term. So if we do that, on one side we'll simply have 1 by 1 plus x square into dx. And whereas on the other side, it's like integral 1 dx minus integral x square into dx plus integral x power 4 into dx minus x power 6 into dx plus and so on. So on one side, I hope we can see that this is tan inverse of x. So tan inverse of x is equal to, we'll get x minus x cubed by 3 plus x power 5 by 5 minus x power 7 by 7 plus x power 9 by 9 minus and so on. Alright, so this is how by using term by term integration we obtain the expansion of tan inverse of x. N minus 1 into x to the power of 2n minus 1 over 2n minus 1. This is valid for all 1 less than or equal to negative 1. Less than or equal to. In other words, the same expression we can write it like mod x is less than or equal to this. Okay. So now I want to move to some problems on power series. Yeah, you can see that. Find the radius and interval of convergence of the power series. For what values of x does the series converge absolutely? Converge conditional. All this you need to find. So the first one I hope we can do it very easily because it is a geometric series. Okay, but anyway, let me quickly do all of these problems. Okay, so we need to find the radius and interval of convergence for it. Okay. So this one, for the first one, we can actually say it from the geometric series or let me just use a root test. I don't want to because it's a geometric series. Why should I use root test here? So I don't use root test. So let me say that it's a geometric series. Geometric series, and here r equals to x plus 5, and we already know that, and it is convergent. Moreover, it is absolutely convergent. If and only if modulus of r is less than 1. Means what? Absolute value of x plus 5. Absolute value of x plus 5 is strictly less than 1. Okay. So now I hope we are ready to write the radius of convergence. Why? Because this power series is centered at negative 5. So therefore, from the center you are actually moving how much distance? Just the distance 1, because this will tell you the radius of convergence. Mod x minus a less than r అని వచ్చింది అనుకోండి, ఈ capital R ని radius of convergence కింద తీసుకోవచ్చు. Okay, so therefore radius of convergence ఏమవుతుంది? Radius of convergence is equal to 1. Okay. But anyway, so let me rewrite that interval. Minus 1 is less than x plus 5 is less than 1. So this one can be rewritten like minus 6 is less than x is less than subtracting, right? So negative 4. Okay. So therefore interval of convergence. Interval of convergence that is actually open negative 6 open 4. అంటే మీరు అబ్జర్వ్ చేస్తే సెంటర్ వచ్చేసి నెగటివ్ 5 దగ్గర ఉందండి. ఇది ఎక్కడి నుంచి ఎక్కడ వరకు కన్వర్జ్ అవుతుంది? సో ఇట్స్ లైక్ నెగటివ్ 6 and negative 4. So that is why the radius of convergence is 1 Okay, and it won't be conditionally convergent. It is only absolutely convergent here. Conditionally convergent are points here. Okay. So the next one, let me move for this. So yeah, this is also a geometric series if you observe. Why? Because this one can be rewritten like this. Summation n equals to 1 to infinite. We can rewrite it like x minus 2 by 10 whole power n. Okay. So it's clearly a geometric series. And here r is going to be mod x minus 2 divided by 10, and you know that it is absolutely convergent if mod r is less than 1. So mod r, which is mod x minus 2 by 10, has to be strictly less than 1. This means what? Mod x minus 2 is less than 10. Okay. So can you tell me the radius of convergence now? So radius of convergence. So r equals 10. Okay. Why? Because the center is 2, right? So x minus 2 is less than 10 here. So that's why the radius of convergence is 10. All right. Now let us look at the interval of convergence. Interval of convergence. So I equals. I hope you can actually see here. This is minus 10 less than x minus 2 less than 10. So minus 12 less than x less than. Is that minus 12? Sorry, minus 10 plus 2. That gives you minus 8. And this gives you 12. Right? So therefore the interval of convergence is negative 8 to 12. Okay. You can actually see the center is at 2. Positive 2. From 2 you are moving 10 units this side, therefore you will come to 12. This distance is 10. Okay. Similarly, if you move 10 units on the other side, you will come to negative. This is the interval of. So this is the interval of convergence. Okay. So I hope you got it. If it is a geometric series, it is so easy. Then no need of checking for the conditional convergence or not. So next, let me pick this problem. E. So here it is not like the previous problem. It is not a geometric series. Okay. Since it is not a geometric series, what shall we do? We will either go for ratio test or root test. Okay. I suggest ratio test here. So if I go for ratio test, even root test also can be applied, no issue. So limit, we need to look at limit and goes to infinite, absolute value of an plus 1 over a. So limit and goes to infinite, modulus of n plus 1 times x to the power of n plus 1 over n plus 3 times this is n plus 2 over n into x power. Alright, so this one can be written as limit and goes to infinite. What happens now? I hope n into, okay, nothing cancels, so fine. n plus 1 into n plus 2 over n into n plus 3. This into modulus of, you can see that x power n plus 1 by x power n, that would be equal to x, right? So therefore you'll have mod x. For the rest, no need of keeping modulus, because anyway that is positive. Okay. And what is its limit? If you want, you can rewrite it like mod x times limit and goes to infinite. Yeah. So upon taking n square out, we can rewrite it like this. The denominator 1 plus 3 by 10. So this would be equal to mod x times what? 1 plus 0, and this is 1 plus 0. The denominator also 1 plus 0. So finally what we get here is just mod x. Okay. ఇక్కడ యాక్చువల్గా డైరెక్ట్ కూడా చెప్పేసండి, ఎప్పుడైతే ఇక్కడ n ఉందో మనకి ఇది 1 కి ఈక్వల్ అయిపోతుంది యాక్చువల్గా. సో x పవర్ n ఉన్నట్టు అంతే. So the limit of ratio test we got mod x, and we know that the series is absolutely convergent and mod x is strictly less than 1. So let us write that. Therefore summation or given series is absolutely convergent. Absolutely convergent for mod if mod x strictly less than 1, right? It means you know minus 1 is less than x is less than 1. The radius of convergence also you know it is 1. Okay, now let's look at endpoints. So what is its behavior at endpoints? At x is equal to minus 1, summation n equals to what is given here? 0 to infinite. Okay. 0 to infinite. n over n plus 2 times x power n. X power n means minus 1 power n. Okay. What do you know about this? Is it convergent or divergent? Yes. It's divergent. Why? Yeah, so if you apply the limit of nth term, you'll get 1. So let's forget about minus 1 power n. The absolute value of nth term is not going to 0. Therefore it is divergent. That's it. By nth term test we can say that this guy is divergent. By nth term test. Okay. So even the other guy is also given at x is equal to 1. That is summation n equals 1 to infinite, 0 to infinite, n into n plus 2. This is 1 power n. This is also divergent. by nth term test. Okay. So therefore it is divergent at both endpoints, right? So therefore what is the interval of convergence? Interval of convergence is nothing but interval of convergence is minus 1 comma 1. Is this series conditionally convergent at any point? So if we observe that this is only absolutely convergent series, it is not conditionally convergent. Conditionally convergent అయితే endpoints దగ్గర అవుతుందండి. రెండు endpoints దగ్గర కూడా ఇది divergent అయింది. కాబట్టి this is only absolutely convergent in that interval minus 1 to 1. Okay. So next let us look at this problem. N equals 0 to infinite x minus 1 whole power n by root n. It's not a geometric series first of all. So either you should go for ratio test or root test. And definitely you may move for ratio test. Root test and apply చేద్దాం. ఈ problem root test వెళ్దాం సార్. Okay, so let me apply root test. So that's limit n goes to infinite modulus of an whole power 1 by n. This is what I have taken. So limit n goes to infinite modulus of x minus 1 whole power n by root n. Okay, this whole to the power of 1 by n. So everyone at the limit n goes to infinite. This is mod x minus 1 n by n. ఇక్కడ పవర్ 1 by n ఉంది కదా, n by n అవుతుంది అట్లాగే. సో దిస్ ఇస్ రూట్ n పవర్ 1 by n. సో limit n goes to infinite. So this is simply mod x minus 1 by. I hope this one can be rewritten like this. 1 by n in local తీసుకురావచ్చు. This is square root of n power 1 by n గా రాయొచ్చు. Because n power 1 by 2 that you can write it as n power 1 by n whole power 1 by 2. Okay. And we already know that what we know limit n goes to infinite n power 1 by n. This limit is 1. Okay. Since this limit is 1, you can say that this limit is mod x minus 1 over root 1. Therefore mod x minus 1. So we got limit as mod x minus 1. మీరు root test apply చేసినా ratio test apply చేసినా ఇదే వస్తుంది. ఏం చేయాలి? Okay. So we know that given series is convergent if mod x minus 1 absolutely convergent. Mod x minus 1 is strictly less than 1. So radius of convergence ఏమవుతుంది ఇప్పుడు r equal to 1 అవుతుంది. Radius of convergence. Anyway, we can write that later also. So this one can be rewritten like this: minus 1 is less than x minus 1 is less than plus 1. Now adding 1 on all sides, minus 1 plus 1 is less than x is less than 1 plus 1. So this implies that 0 less than x less than 2. So మీరు అబ్జర్వ్ చేస్తే పవర్ సిరీస్ అనేది 1 దగ్గర సెంటర్ అయింది. సో 1 దగ్గర నుంచి you're moving to 2 and you're coming back to 0. The distance ఎంత అటు ఇటు మూవ్ అయింది 1 unit. You move this side and that side, left side and right side. Okay. So ఈ ఇంటర్వెల్ అబ్సల్యూట్లీ కన్వర్జెంట్ అవుతుంది. So what about at n points at x is equal to 0 x equal to 0 దగ్గర summation n equals to 1 to infinity a mixture and x minus 1 కదా 0 minus 1 whole power n by root n that is లేదు మీరు ఇంకా క్లారిటీ రాస్తున్నట్టు ఇక్కడ ఫస్ట్ x minus 1 రాయండి then you plug in 0 so 0 minus 1 whole power n by root n and what do you know about this summation? This summation will be conditionally divergent. ఎక్కడి నుంచి వచ్చిన వర్డ్ conditionally convergent. So this is nothing but summation n equals to 1 to infinity. That's minus 1 power n by root n. So this is conditionally convergent. Okay. Next other point x is equal to 2 other end point which is n equals to 1 to infinity x minus 1 whole power n by root n. The summation n equals to 1 to infinity 2 minus 1 whole power n by root n. But 2 minus 1 ante 1 ayga 1 power 1 ante 1. So n equals to 1 to infinity. This is 1 by root n. So how about this one now? It is divergent. Right? So therefore, at the end points, you can see that 2 is not included, but whereas 0 is included. So therefore, we can say that interval of convergence now is interval of convergence is closed interval 0, open interval 2. 2 దగ్గర డైవర్జెంట్ అయినందుకు 2 ని ఇంక్లూడ్ చేయాలి 0 దగ్గర కన్వర్జెంట్ కాబట్టి ఇంక్లూడ్ చేస్తాం. Okay. So and the radius of convergence is 1 that we have already concluded. Radius of convergence that is 1. R equals 1. Radius of convergence interval వచ్చిన తర్వాత కూడా ఫైండ్ అవుట్ చేయండి. ఆ ఇంటర్వెల్ ఏదైతే వచ్చిందో దాని half distance తీసుకుంటే ఇంటర్వెల్ లెంత్ డివైడెడ్ బై 2. That is the radius. Interval ఇక్కడ ఏమొచ్చింది 2 కదా 0 to 2. 2 minus 0 divided by 2 అంటే 1. Okay. And similarly you have many problems here. Okay, I wanted to try one more problem for which the interval of convergence is not finite. So I'll try this problem. So here, if I go for ratio test, since you have factorial, the ratio test would be better. So limit and goes to infinite. Modulus of an plus 1 over an. So that equals limit and goes to infinite. Now this is 3 power n plus 1 into x power n plus 1 over n plus 1 factorial. That is an plus 1 into reciprocal of an which is n factorial by 3 power n into x power n. So this is limit n goes to infinite. N goes to infinite. How much is this? 3 power. I hope 3 power n. Okay, let me take one more step. X power n into x by this is n plus 1 into n factorial This is n factorial by 3 power n into x power. So I hope we can cancel few things here. This and this, x power n, x power n, 3 power n, 3 power n. So finally you're left with limit n goes to infinite. We have 3 times mod x divided by n plus 1. Okay. So this is what we have, right? So now what is its limit? Whatever may be the value of x. For this one you can rewrite it like this. 3 times mod x you can keep it right. So limit n goes to infinite. You'll have 1 over n plus 1. Yeah. And what is the limit now? 3 into mod x times, and this limit will be 0. Okay. And finally we got 0. So we came to know that the limit of ratio test is 0. Okay, and this is 0 for any value of x, for all x belongs to R. X ఏదైనా అవనివ్వండి. 0 into that x becomes 0. Okay. So let's write the conclusion here. Therefore, limit n goes to infinite. Mod a n plus 1 over a n is equal to 0 for all x belongs to R. So therefore, the conclusion is that given series is absolutely convergent for all x belongs to R. You understand? It means what is the radius of convergence? So radius of convergence ఏమవుతుందండి? So radius of convergence would be, can you tell me, can someone tell me? How come the radius of convergence is 0 here? అంటే 0 radius of convergence 0 అని అంటే ఇది ఓన్లీ సెంటర్ దగ్గర మాత్రమే కన్వర్జ్ అవుతుంది. మిగతా ఏ పాయింట్ దగ్గర కన్వర్జ్ అవ్వదు అని చెప్తున్నారు అంతేనా? కానీ ఇక్కడేమో మనం రాసిందేమో ఫర్ ఆల్ x belongs to R it is convergent అని చెప్తున్నాం. సరే నేను ఇంటర్వెల్ ఆఫ్ కన్వర్జెన్స్ రాస్తాను.
Plus infinite.
So interval of convergence is minus infinity. So what is its radius now?
Finite.
It's going to be infinite. The radius of convergence is infinite, and the interval of convergence is the entire real number. That is negative infinite to positive infinite. The conclusion ఏంటంటే ఈ సమ్మేషన్ ఏదైతే ఉందో n equals to 1 to infinite 3 power n into x power n by n factorial. This is convergent or absolutely convergent. Absolutely convergent for all x belongs to R. Okay. So ఎప్పుడైతే మనకి రేషియో టెస్ట్ లో లిమిట్ అనేది 0 వచ్చిందో అంటే ఫర్ ఆల్ వాల్యూస్ ఆఫ్ x ఇట్ ఇస్ 0. x ఏదైనప్పటికీ లిమిట్ 0 వచ్చింది. అంటే x ఏదైనప్పటికీ గివెన్ సమ్మేషన్ కన్వర్జ్ అవుతుంది. That's what it means. Okay. So interval of convergence వచ్చేసి negative infinite to positive infinite వస్తుంది. And radius of convergence will be infinite. Why? Because the length of that interval is infinite. I want to pick just one more problem. So మీరు అబ్జర్వ్ చేస్తే దీనికి కూడా ఇంటర్వెల్ ఆఫ్ కన్వర్జెన్స్ మైనస్ ఇన్ఫైనైట్ టు ప్లస్ ఇన్ఫైనైట్ వస్తుంది. ఈవెన్ ఫర్ ప్రాబ్లం ఐ కానీ ప్రాబ్లం జే ఇంటర్వెల్ ఆఫ్ కన్వర్జెన్స్ హోల్ వస్తుంది. బట్ కేక్ అయితే రాదు. కేక్ ఫుల్ కాదు. విల్ ఫైండ్ లిమిటెడ్ వన్. రేడియస్ ఆఫ్ కన్వర్జెన్స్ అయితే 2 అవుతుంది. బట్ ఎనీవే లెట్ మీ క్రియేట్ ఎ ప్రాబ్లం. ఒకవేళ ఇట్లా ఉందనుకోండి, సమ్మేషన్ n ఈక్వల్స్ టు 1 to infinite n factorial into x power n. Can you tell me the radius of convergence and the interval of convergence here? So if you observe that, if we apply ratio test, limit n goes to infinite, an plus 1 over an. So if I go with it, this is actually limit n goes to infinite. So we came out n plus 1 factorial into x power n divided by n factorial into x power n. So this is n plus 1. So limit n goes to infinite. We can see that this is just n plus 1 into mod x. Okay. And you can see that this limit is going to infinite if x is not equal to 0. But x అనేది 0 అయితే limit 0 అయిపోతుంది. Okay. So it means infinite, it means it's greater than 1, right? Therefore it says that summation n equals to 1 to infinite n factorial into x power n. This is convergent only at x is equal to 0. Okay. And this is going to be divergent everywhere else. అంటే ఒక్క పాయింట్ దగ్గర మాత్రమే కన్వర్జెంట్ అయ్యే సిరీస్. 0 అయినప్పుడు మాత్రమే సమ్మేషన్ 0 వస్తుంది. అంటే మిగతా పాయింట్ మీరు 1 తీసుకోండి, 1/2 తీసుకోండి, ఎంత చిన్న నెంబర్ అయినా తీసుకోండి x ప్లస్ లో. So that's always going to be infinite. So this is an example of a series which is exactly convergent at one point.
Sir, what is the radius?
Radius of convergence is 0. ఎందుకంటే దీని సెంటర్ వచ్చేసి 0 ఉంది. సెంటర్ దగ్గర మాత్రమే కన్వర్జ్ అవుతుంది, అసలు ఇంకెక్కడ కన్వర్జ్ అవ్వట్లా. Therefore radius of convergence, so let me write it here. Therefore radius of convergence is 0. అంటే ఆ సెంటర్ దగ్గర తప్ప మిగతా ఎక్కడ కన్వర్జ్ అవుతుంది. ఏ సిరీస్ అయినా సరే సెంటర్ దగ్గర కన్వర్జ్ అవుతుంది. ఎందుకంటే సెంటర్ ని సబ్స్టిట్యూట్ చేస్తే ఆబ్వియస్లీ 0 వచ్చేస్తాయి టర్మ్స్ కూడా. సో సెంటర్ దగ్గర కన్వర్జ్ అవ్వకపోవడం అనేది ఉండదు. But this one is only convergent at center. That's it. Nowhere else. Okay. So this is all. I'd like to stop here. Let me know if you have any questions or doubts.